Welcome to Data Science with EJD. We're talking generally about validation and tuning in supervised learning. This is the third video in that series. Here, our focus shifts to randomized search and pipelines. Don't forget you can download the code sheets and data sets that I'm using by just looking at the description box, either on Facebook or on YouTube. Just click on that to take you there and you can download the code sheet and then you can follow along and try things out. Like I've always encouraged that if you're working with a code and you see a number somewhere, maybe you see number five, so try to change that five to 50 or 500 or change it to something and see what happens. So that way you learn what the number is there for and all that, right? So let's go ahead and talk about the idea of pipeline. So when you talk about in the data realm, right, there are some keywords you've been hearing like pipeline, workflow, and things like that. So let's see what this is about here as we consider randomized search and pipelines. In the last video, we had actually looked at grid search cross-validation, grid search for cross-validation, grid search for hyperparameter tuning, right? So, and at some point we refer to the idea of randomized search. So let's see how that plays here. So what is a pipeline? A pipeline in machine learning is a sequence of data processing steps combined with a final estimator, and the estimator is the model, and it automates the workflow by applying transformations and modeling consistently in the right order, ensuring reproducibility and preventing data leakage. In essence, you can see a pipeline as a data as a machine learning workflow for short, right? A pipeline is basically a machine learning workflow, if you like to see it that way. So why do we use pipelines, right? You automate sequential data transformations and model fitting by using pipelines. Since there's already a sequence you should go in, so it's easy to automate. You can prevent data leakage, especially important when tuning hyperparameters. You can also facilitate cross-validation on the entire workflow. Then you can simplify hyperparameter tuning across preprocessing and modeling. Then you can create modular and maintainable code. This is really important if you are in a place where you need to automate some processes. So what is hyperparameter optimization then? Okay, I think I should break this up too long. So hyperparameter optimization. So machine learning models have hyperparameters, e.g., number of trees in a random forest that cannot be learned from the data directly. So choosing the right hyperparameters is critical for model performance. In the last video, we saw how to look at that, like maximum depth of each tree and the number of trees in the forest, right? So common approaches are grid search, which is exhaustive search over a grid of parameters, and then now we are focusing on randomized search, which randomly sample hyperparameters from specified distributions. Then why do we use randomized search instead of grid search, for instance? So because of its efficiency, it evaluates a fixed number of random parameter settings instead of all combinations. Then the exploration, right, it can sample from continuous and discrete distributions covering more space. The speed is generally faster for large search spaces. The effectiveness, it often finds near optimal parameters with fewer iterations. So those are some of its advantages over grid search. So randomized search, grid search for hyperparameter tuning, and randomized search seems to be faster. So building and optimizing pipelines with randomized search, some key concepts to understand. We have pipeline steps. So this is a named sequence of transformers and an estimator. Then the transformer itself is yeah, here today. I mean, in recent times, in connection with artificial intelligence, generative AI, large language models, and things like that, transformers they are really popular these days, right? And it's a transformer is simply a pre-processing step like scaling, encoding, and imputation. Right, that's what the transformer is. And to talk about the estimator, the final model that implements fit and predicts. These are the estimators rather. Hyperparameters are actually configurable parameters of transformers and estimators. Then the parameter grid or DIST this gives a range of distributions of hyperparameters to search. Then you have randomized search cross validation. This is cross validation wrapper that samples hyperparameters. Okay, so pipeline components example. So we have a simple imputer which fills missing data using mean, median, or constant. So I mean this in data analysis we saw this as data cleaning, data preprocessing, and all that. So here we have simple imputer which fills missing data using mean, median, or constant depending on what exactly you want. Then we have the standard scaler which standardizes features by removing the mean and scaling to unit variance. So you want the data to be normally distributed. And then you have random forest classifier, which is an ensemble tree-based classifier. So these are some pipeline component examples depending on the task you like to do. Then let's see step-by-step coding guide. Step one, we import the required libraries. So here, from scikit-learn.pipeline, we import pipeline itself, right? And then scikit-learn.impute, we have simple imputer in case they are missing the data, you want to impute them. Then preprocessing, you want to standardize a particular row, a particular column, right? If it's not in the right form, then you call your random forest classifier. Okay, I keep forgetting to put the line numbers, right? Okay, so the standard scalar, the random forest classifier in line 4, and for model selection, SQL and model selection, you have the train underscore test underscore splits, and then because you also are considering the randomized search CV here, in the last video we looked at the grid search CV. Here it's about the randomized search CV, and the data set we're using here is the breast cancer data set. So from SciPy at the start, we're bringing random integers, I believe. On my playlist talking about scientific computing with Python, I started dealing with SciPy. I still have a few of those functions to go. Then NumPy for numerical computations. So don't forget to run so that all the libraries can be well mounted. So once you have a number here, it means they are there. Then you can then load and split the data set. Yeah, so we are working with the breast cancer data set, right? So we just say data equals on load underscore breast underscore cancer, open and close brackets. Then we have X, the features, data.data, Y, the target, data.target. Then we now split into training and test sets, 80-20 split, which is one of the most common. So train test splits, X, Y, test size 0 0.2, random states for the two. Then we stratify with the target. So be sure to run that too. So it's done. Then we now define the pipeline. So that's the key focus of what we are doing here because we're talking about randomized search and pipeline. So you define the pipeline. So here we say the pipeline is equal to the pipeline function into you use the imputer, that simple imputer, and the strategy is mean. So this simply tells you that any missing values will be taken care of by replacing with the mean of all the other values available. Then you have the scalar, which is the standard scalar. So you scale features for better performance, for better convergence, that is. Then your classifier here is the random forest classifier. And so this is the random forest model in this case. So you can change it depending on whatever strategy you want to do. So our pipeline here contains these things. So that's been defined and mounted. And then in step 4, you define the hyperparameter search space. So you use step name underscore param name syntax to reference pipeline step parameters. Then you define distribution using scipy statistics, scipy underscore stats for continuous or discrete variables. So you see param distributions will now be classifier n estimators. This is double underscore, classifier underscore n underscore estimators. So yeah, randomly checking between 50 and 300. Then classifier maximum depth, you're checking from 5 to 30. Classifier minimum sample split, you're checking the sample splits between 2 to 20. Minimum samples leaf 1 to 20. Classifier bootstrap, true or false. So this is number of trees, depth of trees, minimum samples to split, minimum samples at leaf node, whether bootstrap samples are used. So that's there you define the hyperparameter search space. So I make sure you run that and it's down there. So step 5, you set up randomized search cross validation. So here you specify the pipeline as the estimator and use cross validation CV is 5. Number of iterations, that's N iter, that balances time and coverage. N jobs equals -1 to utilize all CPU cores for speed. That's more like maybe some concepts about parallel computing. And then for the random search, now then you now bring in the randomized search CV. The estimator is your pipeline, the parameter distribution your parameter distribution that you defined before now. Number of iterations is 50. That's the number of parameter settings sampled. CV is 5. That's five-fold cross-validation. Because that's in general we have k-fold cross-validation. So K here is 5. Verbose 2 to tell us the process as it's going. Then the random state is 42 to be sure we can reproduce what we are doing. Then N jobs equals -1 to utilize all CPU cores for speed. So I run this now because you have verbose. Okay, I mean, oh, okay, we are not expecting any result here. In step 6, we can fit the randomized search on training data. So just a random underscore search, because that has been defined right here, right? Then random underscore search dot fit X train Y train, and we have that. So because of verbose now, we have fitting five folds for each of 50 candidates, totaling 250 fits. That's 5 folds times 50 candidates. That's 250 fits in all. So you see the star, it means it's taking some time, it's still running because it has a lot of work to do. So we're here. Now it's done, and we have this beautiful thing out here. So we have the randomized search, and you have the best estimator pipeline. So the simple imputer, standard scalar, random forest. So if you want some information about the simple imputer, you can just click on it. It takes you to the documentation page or something. Then the same for the others also. So that's done. Then in step 7, we evaluate the best model. So of all the best model is that model with the best hyperparameters, with the best that give with the parameter hyperparameters that give the highest or highest test accuracy. So here now, so print best hyperparameters found. So here you print random search dot best underscore params underscore, and then you print best cross validation accuracy. So random search dot best score to three decimal places, that is. Then you evaluate on the holdout test set. So test accuracy is random side the score, X test, Y test, and then you also test the accuracy for that also. That's then you run that, and that's just jumps out like that. So here we have the best hyperparameter found. So the classifier bootstrap should be false. Classifier maximum depth is 25. So the number of depths of each tree should be 25. Classifier minimum samples leave is 4. Classifier minimum sample split is 9. So minimum split should be 9. Classifier number of estimates should be 201. So with this combination, that's the best hyperparameters you can do. Then best cross validation accuracy 0.965, and the test accuracy actually is 0.956. So those are very high scores that we can work with. So not a bad one. So optionally, you can actually try to access the best model and use it. All right. So, and the way to do that is, so it means that you do the process again. So get the best model, just a random underscore search dot best estimator. I think we got the best estimator somewhere already. So you train the model again and make newer predictions with that and do the process all over. So, but I won't go into all that. But I mean, that this is like a starting point if you want to access the best model for your use. So the best practices and tips in this case, so data you need to prevent data leakage. So data leakage prevention, always include preprocessing inside the pipeline, right? To prevent data leakage prevention. Then stratify your split when dealing with classification to maintain class distribution. Then set random states for reproducibility. That random underscore state equals 42 that we keep doing. Then use appropriate CV folds based on data set size. Then start with randomized search. Then refine the grid search if needed. Then monitor runtime and iterations to balance performance and resources, because you don't want an accurate model that wastes a lot of resources. Then use n jobs equals -1 for parallelized computations. So for parallel computation, so that the search, because you have a lot to go through, so you have the searches go on simultaneously, so you save some time. In summary, uh, a pipeline, we've seen that pipeline encapsulates end-to-end machine learning workflow for robustness. Then randomized search CV is efficient hyperparameter tuning. It's an efficient hyperparameter tuning by sampling distributions. Parameter notation, you have step name underscore underscore param name to tune steps inside pipelines. Then cross-validation inside pipeline ensures unbiased parameter estimation. Then parallelism speed up search with multi-core processing. Then modular and reusable code. Pipelines promote clean, maintainable machine learning workflows. So you want to have a pipeline that gets some just jobs done automatically, so you don't have to, do manual stuff anymore. So with this, we come to the end of this video. Thank you so much for listening. Let me know how helpful this is for you. If you have subscribed already, thank you for that. If you have not, be sure to do that right away and hit the notification bell so you can always get alerted each time a new video is released. There are membership options on my channel now, so feel free. If you want some extra privileges, feel free to check them out. I currently have bronze, silver, and gold access levels. Feel free to check them out and see how they fit into your own plans. Also, like and share also so that more people can have access to these great resources I have on this channel. Till I come your way again, keep doing data right. Bye.